Jessica is a scientist. She's making a solution of acid. She has two different bottles, each with the following concentration of acid. One bottle is 12% acid and the other one is 5% acid. This means for every 100 milliliters of bottle A, there are 12 milliliters of acid. Work out how many milliliters of acid are in 200 milliliters of liquid from bottle A. Well, that's not too bad. Hey, buddy. So basically, when you have 200 milliliters of bottle A, only 12% of it is acid. So it's 200 multiplied with 12%, which is going to get you 24 milliliters. Okay, that's happy out. Now, Jessica mixes the 200 milliliters of bottle A with 300 milliliters of bottle B. Work out the overall concentration of Jessica's mixture. Okay, no bother. So there's 200 milliliters, of which 24 milliliters is acid. Okay, and we're going to mix that with 300 milliliters, and it's from bottle B, which is 5%. So we're going to get 300 multiplied by 5%, which is 15 mils of acid. So that to me means there's 39 milliliters in 39 milliliters of acid in 500 milliliters of solution. Okay, and we need to figure that out as a percentage. So it's going to be 39 over 500. Now I should have wrote 300 multiplied by 5% earlier, which is our 15 milliliters. Okay, and then we're going to multiply that by 100 to turn it into a decimal, or sorry, turn it into a percentage. And what we're going to get is 7.8. 7.8%, right? So that's handy enough. Okay, let's move on. Explain why Jessica could not make a solution with 4% concentration of acid by mixing liquid from bottle A and bottle B. I think the problem is that bottle B is 5% and bottle A is 12%. And you can't make it weaker by mixing the two bottles together. You can't make that bigger, so she can only make solutions between 5% and 12%. She'd need to use pure water to dilute it down otherwise. I make 5 to 12%. If she's mixing the two solutions, it can only be between 5 and 12%. Okay, happy days. Now to the actual algebra. Oh, never mind. When she's making another mixture, Jessica makes a mistake in measuring. She wants to measure 250 milliliters, but she makes 260 milliliters instead. Work out the percentage error in this measurement. Well, percentage error is error divided by true value. The true value is 250 multiplied by 100. So your error is 10 milliliters. Your true value is 250 milliliters. You multiply that by 100. That will get you a 4% error. Now finally, some algebra. If a solid is made up of faces with straight edges, then the following identity is often true. The number of corners take away the number of edges plus the number of faces is 2. Write down the values of C, E, and F for a cube and fill in these values. Okay. So, how many faces does a cube have? It's like a dice. A cube is like a dice, and a dice has 6 sides, so F is 6. All right. How many corners does it have? 1, 2, 3, 4. Then there's 5, 6, 7, 8. Has 8 corners. And then we're going to test if the formula is true. So it's going to be 8 minus 12 plus 6. And does that equal 2? Yes, it does, because 2 equals 2. You put it in. Happy days. Let's move on. Now, question 2. Each of the faces of a different solid are in the shape of a triangular area of 5 centimeters squared. It has 12 corners, 30 edges. So we're going to find out the number of faces it has. Okay? So here's what we're going to do. We're going to do 12 minus 30 plus f equals 2. Minus 18 plus f equals 2. This must mean it has 20 faces. Because when you move minus 18 over the other side, it comes plus 18. 2 plus 18 is 20. So it has 20 faces, lads. And each face has an area of 5. So 200 multiplied, 20 multiplied by 5 is 100 centimeters squared. All right, happy days. That the algebra is quite easy here, actually. Now, here we go. The surface of a third solid is made up of H hexagons and P pentagons, where H and P are natural numbers. It means they're numbers 2, 3, 4, have to be a positive whole number. Use this equation to find out the number of pentagons in the surface of the solid. I want you to find out the value of P. Okay? Wants us to find out the value of P. Now, please make a note of the negative sign here. This negative sign affects stuff as well. So I'm going to give everything a common denominator. I'm going to give everything a common denominator of 6 in a second. Because I don't like fractions. And they don't like me. And I'm going to give them all a common denominator because I'd like to get rid of the fractions. Okay? Here's what we're going to do. We're going to look at 3 and 2. And what we're going to say is that the common denominator between 3 and 2 has to be 6. So we're going to turn them into 6s. Going to multiply the top and bottom by 2 here. Going to multiply the top and bottom by 3. Now, the only thing about that is that this minus actually makes that a minus 3. Okay? Then over here, it's h, and I'm going to have to multiply the top and bottom by 6 to get over 6. The p, I'm going to have to multiply the top and bottom by 6 as well. And the 2, I'm also going to multiply the top and bottom by 6. This is to make sure that everything is divided by 6. Multiply it out. 2 times 6h is 12h plus 10p all over 6. Minus 3 multiplied by that is minus 18h minus 15p. That's it, minus 15p all over 6. And the next is going to be 6h over 6, 6p over 6, and finally 12 over 6. Now, lucky for us, the h's are going to cancel, so the 6's don't matter anymore. So you can sort of just ignore them because they're on the bottom on both sides, which means they can be ignored. It's the top parts that we're trying to figure out. Now, if we highlight the 12h, the 6h, and the 18h, you can find out quite quickly that 12 minus 18 plus 6 equals 0. So all the h's cancel each other out. And what's going to be left is 10 take away 15 plus 6. And that means there's going to be 1p left over. And this means 1p equals 12. Okay? And that is the answer for 8b part 3. Okay? Okay. So what we're doing next is question 9. Brian buys a new car. The car is shown. So, but basically this point here is 0, 30,000, and that means he bought it new at 30,000. Every year it depreciates by a certain amount. So in year 1 it's worth 24,000 euro, and then all the way by roughly in year 7 it's worth hard to say. In year 7 it's just above 6,000 somewhere, so somewhere above the 6,000 mark. I don't think it's exactly 6,000, but just above it. Okay, now question is going to ask me is, how much was its initial value? Well, we've already answered that. It's 30,000. How much was the value after year 1? Well, we know that that's 24,000. Happy days, all right? Now, Show that the car will reduce by 20% in the first year according to this model. Yeah, absolutely does. Because it reduced by €6,000 because it went from 30,000 down to 30,000 down to 24,000. Its initial value was 30 grand. We're going to figure that out as a percentage, and long and behold, it's 20% when you put that into the calculator and multiply it out. Now, based on this model, write a formula for the value of Brian's car after T years in terms of the age of the car. Use the fact that it decreases by 20% each year. Well, if it decreases by 20% each year, that means you keep 80% of your value. Okay? Same ways, if it decreases by 30% each year, you keep 70% of your value. So, what we're thinking here is that if we say that the value of your car is your 30,000 and you keep 80%, 80% is 0.8 and to the power of t, which is the amount of years. Now check it out in your calculator and see if it works. We go to mode, menu, we go to the table function, and we enter 30,000 and we enter 0.8 to the power. Now see that we want to, we haven't got a t, but I generally use an x. Okay, I press the equals. We start at 0. We do it for 7 years. We do a step of 1. And look, first year is 30,000. Sorry, 0 years is 30,000. First year is 24,000. And then you can go all the way down to, remember we were talking about roughly 7 years was just over the 6,000 mark, which it is. Okay, so this formula will tell us the, we have to use T and we have to use V. Okay, some people might write the answer as phi of T. Phi bracket T means what year you're talking about. I'd be pretty happy with this answer on top here. Okay. Now, what's going to ask me for next is its value after 4 years. Well, its value after 4 years is 30,000 multiplied by 0.8 to the power of 4. You can enter that into your calculator, or you can just go up here and look for the number 4, and it's 1,288. Sorry, 12,288 euro. Okay. Next part then, we have another graph here. The graph on part A is shown below. Okay, so it's been shown again. Oh, sorry, it's the same graph as part A. So it's literally the same graph as part A. Okay, and a different linear model also assumes that the value of car depreciates by a fixed amount each year. The value of the car will also reduce by 20% in the first year, according to this model. Draw a line on the diagram above, passing through the first 2 points of the graph, with holding it. So it wants me to do the same. It wants me to do the same first 2 points. It still wants me to do 0, 30,000, and it still wants me to do 1, 24,000. Okay, so it wants me to draw a line through these 2 points and then continue until it reaches the horizontal axis. Absolutely. We grab a pen, we put it through, oh sorry, won't be grabbing that line. We grab a line, put it through the first 2 and keep going. So see the way it has to go through these 2 points here. And what we also notice is that it finishes after 5 years. Okay, so we did exactly what they wanted us to do. Next question. Hence or otherwise, estimate T, the age of Brian's car, when its value would be 0. Well, its value would be 0 at the point 50, because 5 is the number of years and 0 is the price. So 5 years we're hoping. Okay. Happy days. Now, let's move on. Ava buys a new car for 19,445. She pays 30% of the price as a deposit and makes repayments of this much each month for the following 3 years. So 3 multiplied by 12 would be 36 months of payments, so 36 payments. At the end of 3 years, she pays the additional lump sum of 7,389. Work out the total cost of the car for Ava. No hassle. We get 30% of the price using our calculator. So we put that in and multiply by 30%, and we should get 5,833.50. We're hoping. Okay, menu 19445 multiplied by 30 shift percent. Yeah, we're correct with that number, right? Then we're going to multiply this by 36. So 36 multiplied by your €206.97. And what we get there is 7,450.92. Then after all that, she spends €7,389. I'm going to put the three of these guys into the calculator. So there's one of them. That one's saved as the answer. Here's the second one. I'm going to add them all together. I'm going to get 20,673.42. Okay, so that was handy. Ava drives her car home from the garage a distance of 12 kilometers away. Ava usually drives this journey at an average speed of 60 kilometers per hour. On this day, there are roadworks, so her average speed is only 40 kilometers an hour on the journey. Work out the percentage time of increase it takes Ava to drive home because of the roadworks. Okay. Time equals distance over speed. It usually takes 12 kilometers divided by 60. So 12 divided by 60 is a fifth of an hour, which if you press this button here tells you it's 12 minutes. Okay. The next time she does it at 40, so it's going to be 12 divided by 40 instead. Which is 3/10 of an hour, which is 18 minutes. Okay, so it took her 6 minutes longer. All right, so 6 minutes longer on a trip that usually takes 12 minutes. And we're going to find that as a percentage, because we're multiplying it by 100%. And you'll find that that is going to be 50%. It's the increase of the usual. The usual trip home takes 12 minutes, takes 6 minutes longer. That's a 50% increase right there. All right, guys. Okay. Now, this one here.